You guys will love calculus lecture next year. I'm going to tell you guys right now, it's going to be a very, very, very good time. You will really enjoy it. So, calculus? Oh, yes. You could definitely ask some of the students that they say it's challenging. But I would say if you ask them, they'll tell you that they feel it's easier than pre-calculus this year. We cover, a good amount of material, but it's much more narrowed in terms of its focus. You guys cover a wide range of material in pre-calc. Very wide. We'll never get to that point again. There are some processes that are challenging, but it's much less stressful. Let me tell you that. It'll be a very good time. It'll be a very large class. My guess is we'll be up around 35 to 40 people with all you juniors that are going to be taking this. Anyway, here we go. Today I want to talk specifically about arithmetic sequences. These are sequences that have common first differences. Now, your sheet you're going to have to flip one. It didn't staple the way I wanted to. I apologize. So if you go to second sheet, that's where I'm at right now. Second sheet, not first sheet, second sheet, sorry. So you guys would see arithmetic series. We're going to do arithmetic sequences to start off with. I forgot, so. So what we do is we look for a common first difference. And you maybe remember that quadratics, they have a common difference, but it's in the second differences. And cubics will have a common third difference, and quartics will have a common fourth, so on and so forth. So we want to determine if the sequence is arithmetic, and if it is, we want to find the common difference. So what I do is I simply look at the second term and the first term, and I subtract them. So the second term minus the first term gives me -3. And so right now the difference appears to be -3. How about between 29 and 32? -3 and 26 and 29. So we would say that this is arithmetic, so I would write yes. And then the variable we use to describe difference is d in this situation. So d is equal to -3. So I'm going to let you guys quick do 2 through 6. Anything you don't get done, you'll be asked to do as homework. So we got basically all of it done in class except for a few at the end. So I think you guys should be good to go. So I'm going to pause this right now, and you guys can go ahead and get finish that. All right, here we go. Tenley right now. Tenley's 17 months. So. Okay, we move on. Let's look at 7. It says, given the explicit formula for the arithmetic sequence, find the first 5 terms and the term named in the problems. We did this yesterday, didn't we? It says a sub n is equal to -11 plus 7n. And so if I want to find a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, I'm going to take a lot longer to explain this than what you really need, but I want you to develop the connection. Okay? I would simply plug in 1 or n. So what is the first term? -4. And then I plug in 2 for n, and I get... It says first 5 terms, doesn't it? Well, I plug in 1 for n, and -11 plus 7 times 1, -4. Then I plug in 2, and I get 3. I plug in 3, and I get 10. Now, do you see what it's going up by each time? 7. So the common difference is, right, we know the common difference is 7. What in the problem tells you that's a common difference of 7? The 7n. In fact, if you look, doesn't that look very similar to a y equals mx plus b equation? Or I'll switch it around, y equals b plus mx. Don't those look very similar? Yes, and in fact, they teach arithmetic sequences in Algebra 1 right now because of that connection. So notice that once you can find the first term, you can simply go up by the common difference. Now, if you're asked to find a larger term, say a sub 34, is that what you're asked to do? I can't really read it here. A sub 34, then we do have to plug in 34. So -11 plus 7 times 34. See, 7 times 30 is 210. 7 times 4 is 28, so we get 238. -11 plus 238 is 227. So I found the 34th term and I found the first 5. You don't actually have to plug in 1 through 5. I'll show you how to do it very quickly. What's the first term of problem 8? If I plug in 1, I get negative 45. So that's the a sub 1 term. 35, sorry. A sub 2, a sub 3, a sub 4, a sub 5. Okay. What's the difference? Negative 100. So I don't have to plug in 2, 3, 4, and 5. I can simply just subtract 100 each time. So negative 135, negative 235, negative 335, negative 445. Or 435. I promise if you plug in, 2, 3, 4, and 5 that you're going to get those results. I promise. Now again, if you want to find 34, you got to plug in. So take some time and do 8, 9, 10. Finish those off. Just turn this on. I'm sorry, YouTube Nation, if you couldn't hear me before. Maybe I turned it off. Hopefully you could hear me. If not, hello. All right, so here we go. Given the first term and the common difference of an arithmetic sequence, find the first 5 terms in the explicit formula. Here's how we find the explicit formula. I want you guys to understand as you look at this data right here, okay, a sub 1 is negative 4, a sub 2 is 3. You can plug this data into your calculator, or you could just write an equation for a line given 2 points. That's really what we're doing. And if you think about an equation for a line, you guys have already made that connection. Equation for line is the form y minus y sub 1 is equal to m times x minus x sub 1. Okay? That's a form for a line. Now, we're not going to use that, but I want you to see that what we are going to use is very similar to that. A sub n is equal to a sub 1. What does a sub 1 refer to? The first term plus, parentheses, n minus 1 times d. So I would hope that you could see that there's obviously a connection between those two. And we could generate one from the other. So really what we're doing is we're writing an equation for a line. But now we're looking at terms and we're generating them accordingly. So I know that a sub 1 is 28 and d is 10. What I want to say is that a sub n is equal to my first term, which is 28, plus n minus 1 times 10. I distribute to get a sub n is equal to 28 plus 10n minus 10. I combine like terms, the 28 and the negative 10, to get a sub n is equal to 18 plus 10n. And for sequences, arithmetic ones, they like to write the 18 first and the 10n. They like to have it in that form. Okay, that's what they like to do. Don't worry about generating the first 5 terms. All right, we're going to do more of that later. Go ahead and see if you can write definitions now for 12, 13, and 14 using that. Okay, let's check it out. Flip it over, flip it over, flip it over. Now it says, given a term in an arithmetic sequence and a common difference, find the first 5 terms and the explicit formula. Well, this is a little bit more difficult. You got to help me think through this. I think I wrote this problem down. No, that's not the problem, is it? How about this one? Yeah. So, it says, I want the first 5 terms, and it says, I want an explicit formula. And they tell you that the 38th term is negative 53.2, and that the difference is negative 1.1. Any idea how you're going to find this out? Very good. So, right now, you guys are thinking of a number sense way of working through it, as well as you are. You've explained it using the 38 together. We're going to do that, but we're going to just try to keep things organized. We are going to go straight towards our formula. So I want you to write down our formula as I pause this for the sake of Carly to give her a pass. Okay, so here's what I'm going to do. Yeah, she has a degree in mathematics. Yeah. Yep, she does. Yeah, she's very smart. Very, very, very smart. Okay, so we have a sub n is equal to a sub 1 plus n minus 1 times d. Now, you guys have explained it very well how we're going to solve for this using just our number sense. But let's take a little bit different approach to it. Let's actually solve using our formula so we can keep things organized. A sub n, I'm going to use my 38th term to solve for something here, okay? Namely, in order to do this problem, I need to find out the first term. So to find that, I'm going to use a sub n, or a sub 38 is equal to negative 53.2, which equals a sub 1, which we don't know, plus, if I've used negative 53.2, what is n? 38. Minus 1 times d, which is negative 1.1. So you can see I have all these pieces, so I can use my formula, and using my formula will allow, as you notice, Parker said, take 38 and multiply it by negative 1.1 and subtract it. Well, we're going to do that kind of, except we have to count for the first term in there, so we do 38 minus 1. So there's 37 differences, actually. So what I'm going to do is I just take negative 53.2 equals a sub 1 plus, what's 37 times negative 1.1? Negative 40.7, so add 40.7 to both sides. And if I do that, I get, what, 12.5? Negative 12.5 is equal to a sub 1. Yes? Now if I know a sub 1 and I know the difference, I can write. And you guys, you can cross off that next problem. What's the one below it? 17? Cross off 17. You don't have to do that one. I'll just have you do the one next to it. This will be enough practice for us. Or 18. So you'll do problem 16 next. Sorry. So we got negative 12.5 equals a sub 1. So if I write my formula now, I'm going to have a sub n is equal to my first term, which is negative 12.5, plus n minus 1 times my difference, which is negative 1.1. So now I'm actually writing my formula. We will find the first 5 terms. We're almost ready. So a sub n is equal to negative 12.5 plus negative 1.1n. Yep, you do minus plus 1.1. So to finish it off, a sub n is equal to negative 11.4 minus 1.1n. So I have the I have a formal definition or an explicit formula for this arithmetic sequence, and I want to write the first 5 terms. Well, watch how quickly I can do this. What's the first term? Negative 12.5. We discovered that earlier. And then what is the difference? So I drop 1.1 each time. So negative 13.6, negative 14.7, negative 15.8, negative 16.9, and I did it that quickly. I know. Not enough room there. Probably would have to do it on some sheet paper. Try to do the next problem, number 16, on your own. Try 16 on your own. So 16 looks like, yeah, a sub, what is that? Mine doesn't show up. A sub 40. So you got a sub 40 is equal to negative 1191, and the difference is equal to negative 30. See if you can find the rest of that. If you need more space, maybe you want to get out a scratch sheet of paper, do some work there. No. Okay, so here we are. Let's move to 19. Given the first term and the common difference, write a recursive formula for the next three terms of the sequence after the last one given. Okay, so make sure you put your pencil down. Follow me here, okay? If I tell you that the first term of a sequence is 1 and that the difference is 3, what is the second term? Positive. 4. What's the third term? 7. What's the fourth term? So what are you doing? You're taking 3 and adding it to the previous term, right? So that's what recursive means. Recursive means, as we talked about yesterday, we did do this yesterday, recursive means you use the previous term. And when you use the previous term, if a sub n is the current term, then the previous one is a sub n minus 1. So that means previous. Current and previous. Current, previous. So watch how quickly this goes. All right? If the first term is 3/5 and the difference is negative 1/3, what will you do to find the next term? Okay, so you would make the fractions the same, but you would literally just take 3/5 and minus 1/3, right? So we can write a very, very simple recursive definition for arithmetic sequences. A sub n is going to be equal to the previous term minus 1/3. That's what we do every time, right? We keep on adding something on or subtracting something off. Now, when you write the recursive definition, you also have to identify that a sub 1 is equal to 3/5. So they need somewhere to start. So once we know where to start, we could generate all of them after that. So for 20, you would have a sub 1, or a sub n is equal to what? How would I write this? Yep, you're going to subtract 5 each time as the difference is negative 5. What? Yes, so for 22, you do a sub n is equal to a sub n minus 1, and you just do plus 0.9. And remember to declare that a sub 1 is equal to negative 9.2. And up above here, a sub 1 is equal to 39. Yep, that's the equation right. So let's do one more. 21, what would the equation be? A sub n is equal to what? A sub 1, or n minus 1 minus 2. So, and I say a sub 1 is equal to 8. So if you wanted to find the first 5 terms, watch how quickly this goes. What's the first term? 8. What is the second term? 6. You just took 8 and you did minus 2. What's the third term? 4. 2, 0. Now, somebody asked second hour, they said, well, what's the difference between that and what we've been doing? Well, if you want to find the 100th term, which term do you have to know? The 99. So recursive definitions don't allow you to just go out and find a number, but they're very quick to determine the next. So that's the difference between arithmetic and the other. Okay? All right, we move on. Given a term in an arithmetic sequence and a common difference, find the recursive formula and the 3 terms in a sequence after the last one given. Oh boy. So here's the example. You can cross off the one below it, just like we did before. It says a sub 21 is equal to negative 1.4 and d is equal to 0.6. And we want to be able to find a recursive formula in the first 3 terms. The ones at the bottom. Yes. Okay. So if I'd like to find a recursive formula, which term do I have to know to get started? A sub 1. And we know that a sub n is equal to a sub 1 plus n minus 1 times the difference. So if I could use that formula, I could solve for a sub 1 and be good from there. So let's see if we can figure out a sub 1. What is a sub n? So I have negative 1.4 is equal to a sub 1 we are unsure of, plus what is n? 21 minus 1 would be 20 times your difference, which is 0.6. So negative 1.4 is equal to, what's 20 times 0.6? 12. 21 minus 1 is 20. There's my 21. Okay, so I times 0.6, I get 12 plus my a sub 1. I subtract 12 over, I get negative 13.4 is equal to a sub 1. So now I want to write a recursive definition. So a sub n is equal to the previous term, a sub n minus 1. And what do I do to it each time? I add 0.6 to it each time. And I have to indicate that the first term is what? Negative 13.4. So can you now find some terms of the sequence? The first term would be negative 13.4. What would the next term be? You would do what? And you get negative 12.8. Add 0.6, negative 12.2. Negative 11.6. Negative 11. Okay, we are going to run out of time. Why don't you go ahead and do the next one on your own, and if you didn't finish it, don't worry about the bottom, the 27 through 30. Don't worry about 27 through 30. We'll get to the next page on Monday, okay? You guys can finish any other homework that you're working on. We'll pause right there.